Hello everyone, I'm Dr. Meera Mishra. Friends, in previous we discussed about the law of probabilities like addition theorem and multiplication theorem and Bayes theorem. Today we will learn the topic theoretical probability distribution. Theoretical probability distribution. So friends, what is the theoretical probability distribution? Friends, in day-to-day life, we come across many random variables such as number of meals, number of male children in family having 3 children, or IQ of children, marks scored by candidate in any examination, and number of passengers getting into a bus at the bus stand. So these type of random variables. So friends, for quick analysis of distribution of such a random variables, we consider their theoretical equivalents, and these equivalent distribution are originated according to certain theoretical assumptions and restrictions. Such theoretically designed distribution are called the theoretical distribution, right friends? So basically, friends, theoretical probability distribution are many types of theoretical distribution. Some of them discrete. Theoretical probability distribution are, friends, two types: discrete probability distribution and continuous probability distribution. Discrete probability distribution, and this one is continuous probability distributions. So friend, and discrete probability distribution are two types: binomial distribution and Poisson distribution. And continuous probability distribution are type is normal distribution. So what is the discrete probability distribution, friends? In discrete probability distribution, random variables can take only limited number of values. For example, number of heads in two tosses, like. And continuous distribution, it means random variables can take any value. For example, height of a student in the class, right? So this is the different that is the main difference between the discrete probability distribution and continuous probability distribution. Now our focus is binomial distribution, Poisson distribution, and normal distribution. So what is the binomial distribution? Friends, as you see, binomial distribution is a discrete probability distribution. It is a discrete distribution, and which expresses the probability of one set of alternatives, like success, which is shown by small p, and failure, which is shown by small q. And the binomial distribution, it's also called the Bernoulli distribution. Its other name is called Bernoulli. Bernoulli distribution, its other name. So, binomial distribution is defined by the formula P x equals to Ax NCR TR Q n minus R, which is show the probability of x probability of R success in n trials, right? So where small n show the number of trials undertaken, R show the number of success desired, P show the probability of success, and Q show the probability of failure. Right, friend? And what is the mean of the binomial distribution is NP. And standard deviation of binomial distribution is, which is to show by the sigma, and this is NPQ. And what is the variance? Variance is sigma chi square with NPQ. Right? So this is the binomial distribution. Now take one example and how to apply this formula and solve the question. Now check it. So an example is, in tossing 10 coins, what is the probability of having exactly 3 heads? So because in tossing 10 coins, what is the probability of having exactly 3 heads? So see friends, here the experiment is 10 coins. It means if we take the coin, it means we know that the in case of coin there is only 2 possibility, head and tail. So we know about the success of head is 50% and failure of head is 50%. So it means if in case of coin success is half and failure is q equals to 1 minus p, because we know p plus q equals to 1, so it comes 1 by 2. So p and q value 1 by 2. And here you find the probability of having exactly 3 head. Exactly 3 heads, it means you have to find px equals to 3. So this one is, and the formula is your NCR PR q minus r q minus q to power n minus r. So this one. So friends, I'm using the formula NCR PR q n minus r. So here what is the n? N is a 10 coins. It means here n is 10. Now put the value of 10. It's 7. Now solve this quantity. This is the 10C3, it means combination rule. Now what is the formula for the combination rule? If NCR, it means n factorial upon r ka factorial upon n minus r ka factorial. So here we can write 10 factorial upon 3 ka factorial upon 10 minus 3 means 7 ka factorial. And here this this one is this, because this is 1 by 2 and this is 1 by 2, and this is 1 by 2 power 3 and this is 1 by 2 power 7. It means powers are add. If base are same, it means 1 by 2 power is 10. Now open this, because in denominator there is 7 factorial, so you open this 10 factorial up to 7 factorial. So you have to take value and subtract 1. So here if we take out from 10, so value comes 9 factorial. If we value come 9, it value comes 8 factorial. If value 8 come, it means 7 factorial. So now leave in here, because denominator I have also in denominator 7 factorial here, so this is easily cut down. Now 10 into 9 into 8, and now open this one up to 1. So this is 3 3 the 9 and this is 2 4 the 8. So this value come 10 into 3 into 4, 1 by 2 ki power 10. Now open and solve it. So this value come 10 to 3 into 4 upon 2 ki power 10. So if we solve 3 4 the, this is 120 upon 2 ki power 10. Now you solve this one, find out 2 ki power 10 and then divide. So value come 15 upon 128. Right? So this is the answer based on. So this is the binomial distribution based question. So here you find exactly 3 head. Sometimes it comes at least 2 heads, so it means you have to find the px greater than equal to 2. Sometimes it find at most 2 head, it means you have to find the px less than equal to 2. Okay, so it means if you have to find the less than 2, px less than 2, it means you have to start from 0 to 2. And if suppose it find the at least 2 heads, it means you have to find value of at least 2 head. It means you have to find the value of greater than 2 values, greater than equal to 2 values, right? Now take another one example. Suppose the mean of the given, now take second example, given mean of binomial distribution is given 20 and standard deviation is 4. Now find NP and Q. So you know the formula of the mean formula is NP and a standard deviation formula is root of NPQ, right? So this can be right now. Mean is 20. It means here 20 equal to NP, and a standard deviation is given 4 equal to root of NPQ. Now solve it. Take the root on both sides. Take a square on both sides. So this value comes 20 equal to NP, and this value comes 16 equal to NPQ. So this is your first one equation. This is the second one equation. Now divide equation 2 by 1. So this value comes NPQ upon NP equal to 16 upon 20. So here you NP and NP cancel out. So Q equals to 16 upon 20. So this value comes. So it means Q value comes 4 by 5. So Q value comes 4 by 5, and we know the P is 1 minus Q. It means 1 by 5. Value comes 1 by 5. And what is the N? Now put this value, NP value. So sorry, put the value of P here. So this is 20 equal to NP. It means NP, it means 1 by 5, and it is 100 equals to N. It means here number of trials are 100. So this is the another way to solve the to find the NPQ of the binomial distribution. Now next move on Poisson distribution. So friends, when there is a large number of trials but a small probability of success, so binomial calculation becomes impractical. So we need the another form of distribution. So that one is Poisson distribution, right? So why we need the Poisson distribution? So friends, when there is a large number of trials but a small probability of success, so binomial calculation becomes impractical. For example, number of deaths from horse kicks in the army in different years. So you know there is a probability of success. It's very small probability of success. So in this case, the binomial distribution is becomes impractical. So we need another distribution, and that is Poisson distribution. So what is the Poisson distribution? So friends, Poisson distribution is it is also the discrete distribution. And number of events occurring in a given time period, given the average number of times the event occurs over that time period. So the general term of Poisson distribution is, if you write the general term, of Poisson distribution is defined as Px equal to r equals to e to the power minus lambda ki power r factorial, where r equals to 0, 1, 2, 3 up to 7. This show where lambda show the mean. Here mean is equal to same like binomial distribution, and variance means sigma square. It is equal to mean, means NP. So standard deviation means sigma equals to हो जाएगा root of np, or you can say root of lambda. So this is the mean and variance and standard deviation of the Poisson distribution. So when the Poisson distribution is used, when the number of trials is very large and p is very small, it means n tends to infinity and p tends to 0, such that np remains finite, right? And it is a limiting case of binomial distribution. So it is the limiting case of binomial distribution, right? So now let's take an example of Poisson distribution. Assume that the probability of an individual coal miners being killed in a mine accident during a year is 1 upon 2400. Use Poisson distribution to calculate the probability that in a mine employing 200 miners, there will be at least one fatal accident in a year. So here, friend, given the data, being a killed, assume that the probability of an individual coal miner being killed in a mine accident during in a year is this ratio. It means given the probability, given the success of the killed miners, coal miner is value is 1 upon 2400. Means you have to sense is negative, but you have to take in positive sense, because per year, given how many coal miners are killed in mine accident, so it gives small, it means given the small p is equal to 2400, and use to calculate the probability that in a miner employed 200 miners, it means given the n equals to 200, so lambda equals to np, it means 200 upon 2400. So if we solve this one, 0.083. Now find PR. Formula of PR equals to lambda r e to the power minus lambda upon r का factorial. So now put the value of r factorial. But here you find there will be at least one fatal accident in a year. At least, it means you have to find px greater than equal to 1. It means px greater than equal to 1. It means you have to find p1, p2 up to p200 values. But it is so difficult. So what we do? this value, we know the total probability is 1. So if find the value of this probability, so we can write this 1 minus p0, because p0 plus p1 plus p2 plus p3 up to pn is equal to 1 is equal to 1. Now put the value of p0, 1 minus, it means take the value of r0. So this value is, if 0.083 की power 0, it means value 1. So here e की power minus 0.083 and upon 0 factorial, it means 1. Now you solve this. Now if you want to solve this power, otherwise you have to left here, and this is your final answer. Now next move on. Next distribution is normal distribution. So this is your second one. Now next move on. The distribution is normal distribution. Normal distribution. So friends, normal distribution is a continuous probability distribution. It is a continuous probability distribution. That means random variable can take on any value within a given range, right friend? So first we make the normal curve. Normal curve look like a bell-shaped diagram. It is in bell-shaped diagram. So, and it is a bell-shaped diagram, and it is symmetrical. It is symmetrical because you see on both sides area is equal due to this line, corresponding to this line, and it is a unimodal. Unimodal means it has only one peak. It has only one peak, right? So you can make this form in this way. Right? So friend, so it is symmetrical. Bell-shaped, symmetrical, and unimodal. Unimodal means one peak, right? So symmetrical means since it is symmetrical, it means mean, median, and mode all are coincide in this. It is mean equal to median equal to mode, means all three are same, right? So see friends, its tail, its distribution tail, you see its tail extending infinitely on both sides, right? Or in both directions. Tails are asymptotic to horizontal axis. That means the curves goes to infinity without touching the horizontal line, you see, right? Friends, here you see the x-axis. This is the x-axis. X-axis represent the random variables like height, weight, right? And this is the y-axis, look like a y-axis, and this represent the and y-axis represents its probability density function. This represents the probability density function, right friend? And the area under this curve, friends, you see, and the area, and this the area under this curve tells the probability, right? And the total area under the curve, this is the total, and the total area under the curve is 1, or you can say 100%. In form of percentage, it is a 100%. So if you write here, area under the under this curve, area under this curve tells the probability, and the total area under the curve is 1, or in percentage form 100%, right? Friends, since as I told you, the normal curve is symmetrical, so 50% of the data lie on each side. 50% of data lie on each side. 50% lie in this side, because total area is 100%. So 50% area lies in this side, and 50% area lies in this side, because the normal distribution is a symmetrical distribution, right? So friends, it helps to calculating the probability for normally distributed population. So friends, for any normally distributed data, for any normally distributed data, if I make the normal curve, you see, this is the probability density function, and this is mu, means this is the mean, this is mu, and this is standard deviation 1 minus, and this is plus 1 standard deviation, this is 2 standard deviation, this is plus 2 standard deviation, this is minus 3 standard deviation, and this is plus 3 standard deviation, and this is a mean. It means normal curve is defined by two parameters, is mean and standard deviation, right? So friends, the area between the area, or you can say the mean, plus minus 1 standard deviation covers approx 68.26 area. This area this is 68.26 68.26%, or you can say 68.26 data falls within the 1 standard deviation of the mean, right? And the mean plus minus 2 means this area, this. From this to this. It means the mean plus minus 2 sigma standard deviation covers approx 95.44% area. From this 95.44% area. And friends, in this the mean plus minus 3 sigma standard deviation covers approx I will take in this form, in this way. From minus 3 standard deviation to plus 3 standard deviation, the area covers approximately 99.7%. Means from this to this 99.7%, right? 7%. So almost 100% area covered between this one. Only 0.3% area is across the minus 3 sigma to plus 3 sigma. So it is very less quantity, less area which is lies across these minus 3 sigma to 3 sigma. So we consider the all 100% area covered between this, right? So friends, so these areas of these standard deviations covers approximately area under the curve. Okay? So now learn what is the standard normal distribution. So write down the standard normal distribution. Standard normal distribution. So friends, standard normal distribution, or you can say that the Z distribution. This is also called the Z distribution. Is a way of standardize the normal curve, right? So it is a way of the normalize the standard sterilizing the normal curve. So area of any normally distributed data can be converted to the standardized form using the formula of this one. This one. So actually this is the standard normal area, and for standard normal distribution, mean is equal to, it means mu equals to 0, and standard deviation, it means sigma, its value is 1. So for where what is the Z defined? Friends, Z is a measure of the number of standard deviation, deviation from x to mean, from x to mean, also called z score, also called z score, right? And x, what is x? X is value of random variable, value of random variable, right one. So for friends, for solving any question, so first you convert any normal distribution to the standardized form through this formula, and then use the standard normal table which is provided on your books. Then use the standard normal table to find the probabilities, right friend? So this is all about the normal distribution, the main concept of the normal distribution. So thank you so much for joining my class.